The two cases in which the net present value rule and the internal rate of return rule are going to disagree, or rather, the two cases in which the internal rate of return rule is going to fail, are the cases of non-conventional cash flows, and this is a case where the cash flow signs change more than once, and you'll see what I mean in the example that we're going to work shortly, but the cash flow signs change more than once. The signs of the cash flows here is what's referring to, say, a negative cost and a positive cash flow after that. That's a cash flow sign change, where we go from negative to positive to negative to positive. If that happens more than once, say because we have an investment and then years of positive cash flows and then a negative, say, cleanup cost if we're running a mine, that's non-conventional cash flows. In this case, internal rate of return rule doesn't work. The second case is when we have what are called mutually exclusive projects. And this is the case when the firm has two potential options, but it can only take one of those options for whatever reason. Some of the most common reasons are because it's, say, we have a piece of land that we're going to build on, and so we can only build one thing or another. Right? If I have a piece of land on King Street, I can only build a bar or a restaurant or a bank or a store, but I can't build all 5 or 6 or even 2. I can just take one project or the next. And in the case of mutually exclusive projects, it's possible that the internal rate of return leads us to pick a project that doesn't have the best net present value. And again, you can see how that works in the example that we're about to do. Right? So, non-conventional cash flows. The problem with non-conventional cash flows, you can see when we look at the net present value profile for a problem with non-conventional cash flows, but when we have a negative cash flow in the future, for instance, what we end up with is a quadratic equation, and so we end up with more than one internal rate of return. So for instance, look at this example that we're going to work right now. And here, look at the NPV profile of this example. Right? The net present value profile shows us that there are actually 2 internal rates of return for the previous project. Right? This was a project that had a negative investment, 2 years of positive cash flows, and then a negative cash flow at the end. So you can imagine that this is like a mine. You spend the money to dig the mine, then you produce the ore from the mine to make money, and then you clean up the mine at the end. And what happens there is that when we're discounting that negative cash flow back to the future, that's only going to provide us with a positive overall net present value between certain discount rates. And here that's between 10 and 40%. So we would reject the project if we thought the risk was too low. We wouldn't discount enough. And we would reject the project, again, like normal, if it was too high, because we would discount it too much. So that project, the NPV would tell us to accept, because the required rate of return is in between the 2 internal rates of return, so it's in that realm where we have positive NPV. But the IRR, based on the calculator's answer, will only give us the first internal rate of return. That'll tell us to reject. And so we're only going to look at the net present value in the case of mutually exclusive cash flows. In non-conventional cash flows. For mutually exclusive projects, we can choose one or the other, but we can't choose both. Right? Again, we can look at an example to see how this plays out. So here's our example. We can solve for these 2 values, and we did. We see that if we just look at the internal rates of return for these 2 projects, I would choose project B over project A. But if I look at the net present value for these 2 projects, I would choose A over B. And what we should rely on is the value that's being created. In other words, I'd rather take the $64.05 than the $60.74 because I get more present value from the project. I don't really care that project B is going to give me a 22% internal rate of return, because all that means is I have more room to be wrong about my assumption of risk. But my required return is 10%. That's a really low bar. I could be really wrong and still have positive NPV from both of these projects. So I should be making my decision based on NPV and not IRR. And you can see how that looks, how that works in practice, again, when we look at the net present value profile. What we determined is that at a certain discount rate, we would prefer one project to the other. Because we could solve, remember, we could solve for the net present value of these projects at any possible discount rate. Now we think that the required return, the risk and the required return justify a 10% required return. And at that level, you can see here that the red line is over the blue line, meaning project A has a higher NPV than project B at a 10% required return. But at different levels of risk, we would actually switch our choice. So if you look over to, say, 20% discount rate, you can see that the blue line's above the red line. Project B has a better net present value than project A. In fact, at 20%, project A has a negative NPV and project B has a positive one. Now the point where these two mutually exclusive projects switch is called the crossover point. And that's what we solve for in the problem. The crossover point is here is 11.8%. So that's the discount rate that causes us any required return below the crossover point, we would choose project A over B. Any discount rate above 11.8%, we would switch our choice and choose project B over project A. And the net present value, if I solve at any discount rate, is going to give us the right answer. But the internal rate of return here might cause us to switch our choice. And so that's why we want to use NPV instead of IRR. Now, I'm going to skip the modified internal rate of return. It's not my favorite rule. You should know that there is a way to try to modify the internal rate of return so that it doesn't fail in these two cases.